Okay, this is the worksheet you picked up when you walked in. Get this out, put your name on it. Okay, so we are going to find the perimeter of each polygon. Assume that the lines that appear to be tangents are tangents. So the way to do this, we are going to use that cone head theorem. Okay, find a side that we have a measure to. So look right here. Do you see how we have the measure of 10 right there? If it's 10 on the left, it's 10 on the right. Those are two tangents. They're congruent. They both are going to be 10. So you're going to start with the side you have a measure to, add its congruent part, and then look, this whole side is how long? If this piece from here to here is 10, then what's the remaining piece? Yep. Okay, so we're going to put 10 right there. The remaining piece is 7.9. I'm going to put that to show that that's the remaining piece, is 7.9. Well, if it's 7.9 here, is that a tangent? Yep, so what do I know? 7.9. Yep, 7.9 over here. It's a pattern. We're just going to follow the pattern. And we know that this whole 14.2. So we need to find the remaining piece. I heard it. 6.1. 6.3. Which one is it? 6.3. Yeah, 6. Oh, that's the wrong color. All right, so our remaining piece is 6.3. And if that's 6.3, then what do we know? It's 6.3 as well.
Why wouldn't it be 7.9?
Because 7.9 is only 7.9 is these two tangents. Yeah. Okay. All right, now they want us to find the perimeter. So we already know this side is 17.9, right? We know this side is a total of 14.2. Could we find the total of this side? Yeah, 16.3. All right, now we can get the perimeter. The perimeter is just going to be the 14.2 plus the 17.9. Make this a little bit neater. Plus 17.9 plus 16.3. All right, add them up. Get the sum. Use your calculator. You have them there on your desk. Hey guys, I know some of you have your earbuds in. Those need to be taken out. The phones need to be put away. If I see you on them or you have them out, I'm going to pick them up at this point. I'm not getting your full undivided attention when you're constantly going back to your phone. They should not be out. It's red. Put them away. What's the perimeter? Huh? 38 point what? 48. Okay. Point what?
4.
Yeah. All right, so let's do number 2. Where can we start? The 8.2 and the 14, either one, we could start there. So if I know this little tangent's 8.2, then I'm going to put that 8.2 with its congruent tangent. If I know this tangent is 14, I'm going to put 14 for that tangent. Could we find the remaining piece?
13.8.
$13.8. There we go. We have that remaining piece. So that lets me know that's 13.8 as well. So now I already know the sum of this side. I can find the sum of the bottom side or the left side. We should get a whole number.
22.
Yeah, 22. And then we should get the whole side here. 22 point. Yep, 22.2. And now, how do I know this is a whole number? You should get a whole number for this side. Yeah. All right, and now we're going to do the perimeter. So 22.2 plus 27.8 plus 22. We're going to add all three sides up and get the perimeter. Yeah, it's a whole number. Oops. All right. Extend the page. Number 3. Where can we start? Right at the 12. Yep. So that means over here is 12. If this whole thing is 23 and that's 12, then the remaining piece would be, no, 11. There we go. So if that's 11, then over here, its congruent tangent is also 11. And if that's 9.8, this is 9.8. So now I can get that total side. 9.8 plus 11, 20.8. And I can get the total side here. Huh? Yep, 21.8. Now we're ready to do the perimeter. Questions on this? No. All right, this is using cone head. Okay, this problem's finding the perimeter is using the cone head theorem. Yes.
If we need it, never.
All right, so I'm going to go to the next section. You're going to do 4. Let's look at number 5. Okay. Here it says solve for x, assume that lines appear to be tangents are tangents. So, again, we're using cone head because 5x, is that a tangent? Yes. Yes. And then 4x plus 1, is that a tangent? And what do I know here? They're congruent. This 5x is equal to 4x plus 1. That's what we're going to write. We're going to take its value, the expression that represents the tangent, make them equal to each other because they're going to be congruent. This should be nice and simple. Solve for x, right? We're solving for x. What's going to be our answer here? 4? Yeah, 1. Minus 4x, minus 4x. That's just x equals 1. We're done. Okay? So, look at 6. Would 6 be also cone head?
Yeah.
Yeah. All right, so let's just set it up. We know that tangent.
2x plus 6.
2x plus 6 equals 3x minus 6. Again, this should be nice and simple.
1x.
So which one do you want to subtract? I would do the 2x. I would start with the smaller. That makes it easier. All right, so 6 equals x minus 6. Yep, x equals 12. Because we're going to now add 6. X equals 12. Got it? All right, let's look at the next one. Is that the same problem? Oh, almost. Number 7. Cone head again. What do we write? 4x plus 3 equals 5x minus 1. Let's solve for x. Start with your smallest variable. Yeah, when it comes back. Yep, 4. You still got x equals 4. And add 1. Questions on this type of problem? 8 is all yours. Now, same thing, yep. Oops. I need you to look at 9 with me, because this one is we're gonna practice this a whole lot more tomorrow too. We're gonna do these together. So, again, those lines that appear to be tangent are gonna be tangent. So which line do you think is the tangent? The 16, yes. Okay, what is the x in the circle? The radius, all right. I'm gonna put an R. I know it says x, but we're gonna say that's the radius. This is our tangent. What happens, tangent, and put tan. What happens when the tangent and the radius meet? Put the right angle, all right? All right, so now do y'all see what type of triangle we have in there? Yeah, we have a right triangle, so we're gonna do a squared plus b squared. Now, I need you to, we're going to combine this together. We're going to write our hypotenuse as, so close, 8 plus x, okay? 8x means 8 times x. We're going to add them together, so that's 8 plus x. All right, so we're going to do a squared plus b squared equals c squared. And we're going to require you to kind of think back to Algebra 1 on some fundamentals, some skills that you built. A, what could represent A? X, so we're going to put x squared. B, what could represent B? So we're going to put 16 squared. And C, our hypotenuse? Yep, 8 plus x squared. All right, so get that written down. I want you to understand, because we're adding a number to a variable and we're squaring that, basically we're saying that we have 2 factors of this, 2 groups. So if I square it, I have 2 factors of that. Then we're going to just simplify this left side. Well, x squared is still going to be x squared. Can we figure out what 16 squared is? What is that? 256. All right. Does anyone remember how to multiply a binomial? What are we going to do? Yeah, we're going to do FOIL. 8 times 8. You can do your distributive. Hippity hoppity, distributive property. We're going to do each one. So 8 times 8 will give you 64. Okay. Then I'm going to do 8 times that x. So plus 8x. Then I'm going to go to the next one, which is x times that 8. Again, it's 8x. Plus x times x. X squared. There we go. And we're going to simplify this. All right, when I simplify it, I really have x squared plus the 256 is equal to 64 plus 16x plus x squared. All right, you want me to show you a shortcut? All right, so I'm going to go back to what we have right here. We have a binomial, that means 2 terms raised to the second power. The easy way to do this, take your first number, square it. What is 8 squared?
64.
That's what we had right there, right? Take that number, now add the x to it, so that's 8x, and now double it. When you double that 2 terms, is that what we have right there? Then take the last one and square it. What's x squared? X squared. So square, double, square. Square, double, square. Does that make sense? Okay. All right. So we're going to simplify this. When I simplify or solve for x, I'm going to end up saying minus x squared. This is why I'm going to like these, because look what happens. The x squares cancel out. Write that down. They're going to cancel out. And now we're left with 256 is equal to 64 plus 16x. Can we solve for x now?
Yeah.
Yep. We're going to do what now? Subtract the 64. So we left with 16x was 256 minus 64. Two 256 minus 64. Yes, thank you. 192. All right, and now we got to solve for x. Divide by 16. 16s will cancel out. 12 equals x. Nope, don't, No. No. All right, so let's set up the next one. Add what first? Yep, our hypotenuse.
6 plus x.
6 plus x, yes. Remember, this is going to be perpendicular. A squared plus b squared equals c squared. Let's plug it in. What's going to be our a squared?
Okay.
All right, x squared. What's our b squared? Yep, 12 squared. What's our c squared? Yeah, 6 plus x squared. All right, let's go ahead and simplify. I'm going to scroll this up. All right, so x squared. 12 squared is 144. All right, let's see if we can do the trick. What should we do now? 36. Okay, that's square root of 6. And now, do what? Yep, becomes 12x. And then, x squared, yep. Square, double squared. All right, and then, look what happens. The x squareds are going to cancel out. Oops, how did that happen? Really? How did I move that? Okay, I don't know what I just did here. All right. X squared, they cancel out. 44, 36 plus 12x. What's our next step? Subtract the 36. Good. All right, we're rolling. 144 minus 36. Yep, 108 equals our 12x. Divide by 12. And x equals what? Yes, x equals 9. Got it? All right, let's look at the next set. What are we doing on 11? Anyone remember? Huh? Conehead, yes, conehead. What about 12? Conehead again. All right. What about 13? What we just did. Pythagorean theorem. Okay. 14. Conehead again. All right, we're on a roll. Now, this next page, real simple. Let me show you something. Look at the first one. What do you think x is?
17.
17, we're done. No math. That's the radius? Yes, that's the radius. X is 17.
Wait, so number 2?
Yes, it is 13 because what happens, you see that we have a chord here? And you see that box? Whenever that happens, they get bisected. And they're going to always be the same.
Wait, so number 5 is 10?
Well, hold up, let me find 5. Number 5?
No, 15.
Okay, 5 is different. Because this 12.7 is 12.7 here, and now we're looking at what you have to do. Now we're back to, Pythagorean theorem. Because that x is the leg. So if the x is the short leg or the smaller part, then you're using Pythagorean theorem. But if we're looking at, like number 4, you see there's really no math on number 4? What is the x on number 4? 15, we're done. Huh? Number 3? It's 10, we're done. Here, you have to do Pythagorean theorem. Okay? All right, so we're going to finish working on this tomorrow. Don't forget, let me show it to you real quick. Because I forgot to not close it. All right, this was your homework we started on in class. The back is due tomorrow. We're checking it tomorrow. I'm going to post a video explaining just to remind you. If you're done, you can put it in the tray. This is a grade. Okay? Check out Moto.